I'd like to begin, actually, by acknowledging someone who had a great effect on me. Let me say, number one, that the most important single event in my own professional career, in my development, was my doctoral thesis. I had three advisors, Ed Merrill, Larry Evans, and Ken Smith. But Ken was the predominant one, and I strongly gravitated to him. I also had on my committee Tom Sherwood and Ed Gilland. Talk about heavy duty. I mean, you don't get to meet and talk with somebody who has a dimensionless number named after him very often. And that was always a pleasure, and he was quite a gentleman. But the person who made my thesis was my advisor, Ken Smith. I feel that he taught me engineering by example. And he had so many characteristics that I picked up that I hear today. And that today has been overwhelming and kind of interesting, because when you live your life, you don't always know how you're coming across. And some things became very clear to me that I wasn't always conscious of. And most of them sounded nice, so it was pretty good. But Ken taught me about, number one, clarity of thinking, rigor of thinking, and worrying about the details that matter. He taught me about writing. He had a way of picking the minimum number of words with the maximum amount of information. And so I learned to imitate him. I actually learned writing from another person, one of the people in the atherosclerosis project, Bob Lee's, an excellent writer. And they were always rewriting my stuff. And I learned a lot from that. But Ken, by far, had this enormous effect on me. And I can illustrate that with a short story to give you an idea about the subtlety and nuances in his communication. This was a meeting of the American Institute of Chemical Engineers in Puerto Rico, the first and only one down there. It was the end of my first year. It was in May 1970. I was totally wiped out. I mean, that was a very difficult year. Teaching 2 new courses, starting research. So I got down there, and there were 3 things that dominated: the sunshine, the palm trees, the beach, and rediscovered pina coladas. Now, I had not done much to prepare my talk. What I did was grab a lot of slides from my thesis, put them in a container, brought them down with the idea I'll organize it when I get there. I mean, I'd already gotten into that habit. But after the pina coladas, I sort of lost interest. So I decided I'd give my talk with the slides. I mean, I had talked about it. I should know what I'm doing. I gave my talk. I was also chairing the session. It was on artificial organs. It was the first time the AACH had done it. And I found 4 other people in the country doing some engineering work. And by the way, the group I found, we stayed close together because there were only a few of us. And it was interesting in the beginning. Anybody who was doing biomedical work and chemical engineering knew about all the others. And we'd all go to the same meetings. Anyway, when I got done with my talk, I sat down and I looked over to Ken to get some approval. And he turned and said to me, "Clark, that was the worst thing I have ever heard." Now, those of you who've gotten some criticism from me, now you know where I get it. And Ken was like that. If he got annoyed with something I do, he'd throw chalk at the blackboard and utter a few curse words here and there. He wouldn't put up with stupidity. And you were stupid half the time. But the value that I got from him made it so worthwhile in just the way he thought and the way he could analyze things. And those good characteristics that you may see in me, I think I got a lot of them from him. I think I had my curiosity and my devotion to detail before I met him, but he sharpened a lot of characteristics. And the original concept of this kind of symposium came from Robert Bratzler. Is Bob still here? Yeah. And he wanted to honor Ken and I together because he felt he had learned a lot from the two of us. And there's at least 10 or, no, there's probably 15 people we co-supervised together in what was an excellent collaboration. But for medical reasons, he dropped out of running it, and then I decided to retire, so the department made it just for me. But I wanted to make sure Ken got mentioned because he was a big part of my experience at MIT, and I'm sure those of you who experienced his supervision, co-supervision, know what I'm talking about. He was a really good colleague. So I want to start by thanking the people who worked on this symposium, an awful lot of work. Number one, Kathleen Brianna. Where's Kathleen? Way above the call of duty. And number two, Keith. And I thought Keith was retired. He had told me he retired. And then when he started to complain about how much he was giving up of his responsibilities for what he had to do, I said, I thought you retired. Well, not exactly. I'm advising 2 companies. I'm CEO of a third. Oh, my God. So I felt that after all the work, and you don't know half the story of what went on behind the scenes. Both of us spent about a week in hospital within the last 3 weeks. I had some crazy stuff going on in my head. He had kidney stones and wound up having multiple operations as late as yesterday. And I've had time to recover from mine. So I want to recognize his efforts. He knows nothing about this. Keith, would you come up here? I wanted to get you something that was you'd be proud of and also useful. So, and this is the first time I've seen it, because Kathy helped me get it.
What the heck?
It's a vase, a crystal cut glass vase. And it's got an inscription.
Not easy to
You're going to have to refold it to carry it. So, here it is. And it's got an inscription, I have awarded him another degree. It says, you got to hold it up to see it. It says, world's first PhD squared. Awarded fondly to Keith L. Dion. This is difficult.
I can't hear you.
World's first PhD squared. Awarded fondly to Keith L. Dion for exceptional service in chairing, the title of the symposium is here. I won't read it. Through the authority of Professor Clark K. Colton. On behalf of the MIT Department of Chemical Engineering, 2026.
Bart, thank you.
You're welcome.
It's been a privilege. It's been a privilege to hear all the stories from everyone today, too, about Clark's influence, many things that we went through together, all of us who went through the labs, but also just the legacy that I believe has affected the lives of many people in this room and many, many people outside of this room from everything that's been done. So thank you, Clark, from all of us to you.
And thank all the speakers. It really has been overwhelming, and I'm sitting there saying, so who is that guy? How did I pick him? Why did I pick him? Because he's a 0 or 1 guy. Number 1 guy is in the lab 100 hours a week. He never leaves it. He just keeps going. He can do an enormous amount of work in a short time. 0 guy, you don't see him because he's out practicing for a marathon or running a marathon or a 200-mile bike ride, or he's scaling Kilimanjaro or what other peak he wants to climb, and he's competing with his kids all the time. He didn't have kids in those days, but his personality was the same. So I figured, I was hoping I'd get number 1 guy, and I did. And I have 2 little stories to show you what number 1 guy was like. Okay, first story. Keith has been in the lab, I don't know, 2-3 years, amassed a lot of data, thought he was almost done. And he wanted to meet, Martin Yarmish and I were co-supervising thesis, because the idea of oxygen, Keith, Martin, or Maish as he's normally called, had raised the idea, does oxygen play a role? He and I talked about it, decided it was a good thing to work on, and we offered it to Keith. So he asked to meet with us to go over his data, and we hadn't seen it. He had 160 runs. Each one was a piece of graph paper, and it was put on the table in room 360, the Lewis conference room, filled the table completely. We spent about at least 2 hours looking over the graphs. Do you remember this?
I remember this.
Okay. And then Maish and I decided we would get together and talk privately. And we talked privately for a half hour and came to a conclusion. And we came back and we said, Keith, it's garbage. Keith, the data is totally inconsistent. It's not your fault. It has to be the insulin measurement. And we had given all the insulin assays to Joslin Diabetes Foundation. They had one floor of labs for doing assays. Why not? They're one of the best in the world. We were using what was called an enzyme-linked immunoassay. In those days, it was fairly new. Not a lot of people knew how to use it. They used it. And we figured their data must be good because they're one of the best. But it just didn't make sense. And we said to him, you have to repeat it all. Keith hardly made a peep, maybe a little peep, but he didn't quarrel, he didn't plead, he just turned around, walked out, not too happy, and just went to work. Well, let me tell you that Keith wound up with some of the most amazing data taken by any student at any time, anywhere. Number 1, he built, and this wasn't part of the essay, but he built what I think was the first microreactor, and you know, today those are the rage, little mini microfluidic devices. Well, he built one with living cells in it, and I think that's the first time that had ever been done. It had been used in chemistry labs for experiments with catalysts and things. So he had living islets in this little microreactor with the thinnest tubing anyone had ever made. And he was looking at the secretion of insulin in response to a step change in glucose concentration. The data in the literature showed 2 peaks. First peak took a couple of minutes. Second peak didn't come out till 10 minutes. This was very typical. We were suspicious of it because of the size of the tubing. Keith showed that the first peak came out in seconds and maybe 10 seconds for the second peak, something like that.
Quick.
2 orders of magnitude quicker. And we concluded that all of the data in the literature was a measurement of Taylor dispersion in the tubing. Totally erroneous. Got no relationship to anything physiological, yet it was what people looked at. Now, certain things they could conclude about what comes first and effects, they could make relative comparisons, but they couldn't say anything absolute about the rates. This was amazing. But what was even more amazing was his data that showed effects of changes in oxygen within a second. You change the oxygen, boom, the insulin secretion changes. He actually put up, I think, 1 graph,
Yep.
but he didn't comment on it. And that's his mistake and our mistake, because we put it in a chemical engineering journal, decent one, I think it was Biotechnology Progress. Nobody knew anything about islets, ever saw it. It is not among my top 50 cited papers, yet it was so important. We published his data on the oxygen effect, with not much about the equipment. We put that in the right place. We submitted it to diabetes. Did not get that much attention in the beginning, and I'll comment on that later. Eventually it did, and now it's my most cited research paper, which says something about its importance. I had another paper that got more attention, which was a review, and I'll refer to that in a second. So people are reading, understanding now what's in that diabetes paper. But the one that went into the Chemical Engineering Journal just didn't make a blip. And that's unfortunate. And I was curious, did we influence the data by other people? And I looked, and the state of the art is still 10 minutes to second phase. We did not puncture that. People now understand the oxygen effect. But the fact that the kinetics really are 2 orders of magnitude faster has not gotten through their visual cortex. They could see it, but nobody seems to have picked that up. And the entire community is still thinking it's a slow process. I was a little upset about that, but I realized the important information we were focusing on got out and has now made a big impact. But the methodology, we glossed over, just like he glossed over. He was pointing to what was important, the oxygen, but we forgot the methodology is important. Everybody else who's using it for other kind of studies, they're still getting lousy data. So that's one of the things in research you got to realize. And I didn't realize it till just now. Anyway, the other thing I do want to point out is that we have had a hard time communicating with endocrinologists. Not many people were affected when we first published the work. And I think the people who were engineers certainly did, but there were not many in the islet field at that time. Then I got the idea. Actually, I was working with Giener Incorporated on the sensor, and I got the idea to, I came to the conclusion that the work we were doing with Baxter was wonderful, but it wasn't going to work with islets. That even if we induced blood vessel growth right next to the barrier membrane, the oxygen wasn't high enough to diffuse the distance needed to get it into the islets. Don't forget, physiologically, every islet sees a capillary. He showed you pictures of that. But now, so you got a little distance. Now you got these big distances between the capillary outside the membrane and the islet tissue. It wasn't going to work. So I thought you got to provide oxygen at a higher concentration locally, right there, so you get enough into the islet. And we did some work with, yeah, you're done. Flowers, your wife can use it. Even use it on the, out in the campaign flowers.
This will have flowers for my wife in it.
Okay. And I was consulting with Gainer, and I was at a meeting when they were talking about their own research planning, and they mentioned the word electrolyzer. And I had enough background to know, electrolyzer, they use that to make oxygen. Can you make a little electrolyzer I could implant in the body? Never thought about it. We could try. Right there was born the idea of in situ oxygen supply from an electrolyzer. And I had one student, Chinese woman. I gave her the project, and the first one was in vitro with cells, just to show they grow better if you supply oxygen right there. It worked. It was presented in 1995 at a meeting, I think it was 95, yeah, or I think so. Last minute, I couldn't go. There was something with my wife, Ellen, and she was either ill or something with my kids. Last minute, I decided I'm not going. I sent Hyan. Reports back was from at least people I knew, best paper at the conference. But it had minimal impact. Only the engineers understood. A lot of people didn't believe it. And I wrote proposals, and I had some of the same reaction that Bob Langer has had. I would get them reviewed with some well-known elite endocrinologist reviewing, saying, this guy doesn't know what he's talking about. It's well known oxygen doesn't affect islets. I was told that in 2 proposals, not funded. Very hard to get money for it because it was a foreign idea. And there is something about the field of endocrinology and surgeons and people in the transplant game that is very weird. It is dominated by ego and NIH, not invented here. And there's one person in particular, you probably know who I'm talking about, who dominates the field, and if it doesn't come out of his lab, he doesn't like it. And he gave us a lot of trouble for many years. But what's happened is suddenly they figured it out. Oh, yeah, I want to get back to the review. I wrote a review in 95. The paper from this conference came out in 99. They're in the notes you were handed out, by the way. Those notes have more detail than Keith covered. For those who are interested, it's handed out because we realized it wasn't going to be for a 10-minute talk. So he cut the talk down. You've got the background. The paper was called Hybrid Artificial Internal Organs. It was a review. It was a very unusual review. Why? Because I had consulted for almost every company in the field, and I knew every device was failing, that they had dead islets, and they never talked about it. And if you only read the literature, you would think they were promising devices. None of them were working. They had dead cells in the middle. And I looked at it and said, oxygen. So I managed to talk all of them into giving me photos of the devices with dead cells. Amazing cooperation. And I published all those pictures with an analysis. And I said, oxygen supply will be the most difficult problem to solve with immunoisolation devices. Nobody believed it. And the field made no progress, and I was the only one working on this for at least a decade or two. Today, it's all over the place. Even the JDRF, who turned down one of my proposals, is funding, I don't know how many, but quite a few projects, including about a half a dozen of Langer's former students. Even they have swung up. They argued with me for years that it didn't apply to what they were doing. And so it remains a problem to be solved. I think people are making progress, and maybe they'll get there. Nobody has discovered the remaining problem, which is you can't just make oxygen. You have to monitor it, because there is cell death due to aging slowly. And if you put a certain amount of islets in there alive, over time, some will die. What happens? It's next to a gas space. The gas level goes up. Well, Clercos and I, and lately mainly Clercos, has done work that shows that if you get too high, you start to kill the islets. And there's a region, a window, which is the highest you can get before you get any death, and then the highest you want to be to kill them all. You got to get to the bottom of that window where there's no damage. Otherwise, eventually the oxygen you're making will accelerate the death. Nobody's figured that out. Well, I've been preaching that for a decade. Couldn't sell a proposal, went to the wrong study section. There are all kinds of weird things that happen. And I'd love to work on it, but I don't have the wherewithal right now. But who knows? Maybe we'll get that done. All right. The next thing I want to do, I'm just going to go a little bit. I told you only one story about Keith that illustrates how hard he can work, how dedicated he is, how little he complains. And when he does complain, you got to listen. Second story, it takes place in Igls, Austria. There was a meeting on pancreas replacements. It was both electrochemical, not electrical, it was sensors, electromechanical system, and islet transplantation in various forms. And I took him along, and I don't know, did I give the talk or did you?
I think you did.
I gave a talk, but I thought it'd be educational for him. Besides, he liked to ski, and Igls had a ski thing. And then we discovered that Innsbruck was an hour drive away. And Innsbruck was the site of the Winter Olympics in 1964 and 1976, a few years, 5 years before we were there. And Keith said, I got to go ski there. I said, yeah, it'll be fun. So we got there. We immediately split. He went black, and I was green and a little blue. And we skied apart all day. We agreed to meet at 3 o'clock because I had a flight out of Innsbruck or Igls. It was a small, what?
I think it was Innsbruck.
Innsbruck. Okay, I had a flight to Milan to see some company. And I don't know what he was going to do, but he was going to take my car and return it, rental car. So we met at 3 o'clock, and Keith says, can I do one more run? I mean, this place is just incredible. I want to do the slalom run or something like that he hadn't done. And I said, okay, but you've got to be here at 3:15. He says, no worries, no worries. 3:15 comes, no Keith. 3:20, no Keith. 3:20. 3:30, he shows up and says, hi, sorry, took a little longer. I said, Keith, you're driving me to the airport, and if we don't make it, you're driving me to Milan, which was a big trip from Austria. Okay, we hop in the car. He's in the front driving. I'm in the back changing out of my ski suit into jacket and tie. And I got a paper map. This is before iPhones, way before. No digital, no nothing. It's this big map. And I'm trying to figure it out. It's in German. Anyway, we get on the highway. I see where the airport is. I think I'm doing okay. We get just outside Innsbruck. I'm supposed to make a turn. I missed it. So now we got to go to the next exit and come back. And it was a long exit. And I'm in the back saying, Keith, I'm going to miss my plane. You got to step on it. We got into the city. It's an old European city consisting of straight streets with square edges, one lane about this big. And did anybody here see the French Connection? Okay. French Connection is the wildest police car chase ever, with the drug guys being chased by the police. And they're under the New York City subway, elevated, going back and forth, crazy. That's what we were doing. He was driving 70 miles an hour down these blind alleys. No, you had no idea what was coming the other way. No stop signs, no lights, nothing. I'm going like this. And I'm still getting dressed. All of a sudden, the airport appears. We jump out. He says, run, you run, I'll take the baggage. We ran into the airport. Silence. There was not a person around. They wrapped it up and gone home. But on the runway, my plane was there. And they still had the stairs. The last passenger was getting into it. It was a small jet. So I start running out the door with my coat flinging in the back of me because it was windy. He's running behind me with the bags behind him. We're both screaming, wait, wait. And then a third guy appears out of another door who says, you can't go there. And he's running after Keith. It's like the Three Stooges. So I get there just when they're about to lift the stairs up. The stairs went into the plane. And I'm screaming, holding my ticket. So they stopped. I got up. The stewardess looks at the ticket, says, okay, I'll take it. One seat left in the back. Then his head pops into the plane, and he's dragging the luggage behind him. And last comes the guy screaming. Well, by that time, I was seated. They put my luggage in the compartment. The guy backed down, and I flew out in an amazing flight with the Alps on each side. It's amazing to fly out of the Alps. And I got to Milan, and he went wherever he was going. So that's my second story to show you that he delivers.
Let me add one comment to that. They caught up with me on the Tarmac and started yelling at me in German, but I didn't speak any German. So I was just walking back. We still had the car running in the parking lot. We didn't even turn the engine off. They followed me all the way, yelled at me. I got in the car and drove off, and that was that.
I'm just going to go. Can I go a little longer? A little bit longer? Okay. Anybody who's got to leave, feel free to leave. I'm going to just tell you just a few minor things. I want to thank, these are stories about Keith. I got stories about a lot of my students. And I just maybe I'll mention one or two things. First of all, Jay Schnitzer. He didn't tell you. Jay got an award from Time Magazine, Man of the Decade. It took him 10 years. He is the only student in history to decide to go to med school while doing a PhD thesis. He didn't do it after the end. Was Jay here? Yeah. You didn't do it like you described. You decided after about 3 years into your PhD thesis, okay? And it was like, Jay was a marvel, and I didn't think it was a great idea, but why say no? So far he's done a terrific job. He was developing autoradiography for us, but it wasn't complete, and he was lucky because sitting in the lab was Eric Morel. Is Eric here? Yes. And Eric had to use the technique, and you disappeared on him, So he continued to develop it. And he kept the seat warm because you would come back every other term. I don't know how you scheduled it. You'd come back, do some experiments. Eric was there to clean it up, maybe check it out, get you ready for your next experiment while he's doing yours. Amazing cooperation. And the timing was perfect. And in the end, they both got the degrees around the same time. And we gave you an award. I had Arco draw it up. And I was looking to see if I had a photograph of that. I couldn't come up with one. But I couldn't call you to bring it in. Okay. I think it would be great to show everybody. We really did it. Okay. Oh, tennis. All right, tennis. I just want to say I didn't. Okay. Well, we will skip the farewells. Just a few stories. Just a few stories. What? Okay. I didn't lose every match when I had a partner. I had another partner. I was, bye. My partner was Andrew Zidney. Now, we played together a lot out in there used to be more tennis courts right here. We go out. He never lost to me, ever. But we played as partners. And when I played with Andrew, I never lost. So don't let George make you think it was all disaster. It depended who I played with. Martin Yarmish, the quickest mind. Before I go to Mesh, Andrew again. Andrew is the best teacher that I've ever met. Andrew had the ability to handle very complicated mathematical equations for a very complicated system. We had a suspension in boundary layer flow, red cells. We had to worry about rheology and reinvent blood rheology. We had to deal with a phenomenon that was dealt with in the most esoteric terms by people like Andrew Akrivos, and that was shear enhanced diffusion of particles, and come up with our own formulation. And they put it all together in very complicated math using stuff he barely understood. And we were able to predict the results, truly amazing. But the really great thing that Andrew did was explain what was going on. And Andrew has the ability to take complicated mathematical results from very complicated equations describing incredibly complex situations and explain it in a way that you can understand it. And I was amazed, and I have to say I learned more from him than any of your student because he'd explain his result. And when it was all done, I'd say, great. Thank you for explaining to me. Well, Andrew has now won the award as the best teacher in the university, I think at 2 universities, right? Delaware and Penn State. Best one in the university. So I'm not wrong. He really has this ability as a teacher, and it just adds to his abilities as a researcher. Mesh had the quickest mind I've ever met. Extraordinary. Let me just tell you, he passed the doctoral exams the first time he took it after 1 term here. He had never taken a physics class, never taken any engineering. He came here, he read a few texts, but mostly he studied solution books and understand how to solve the problems. Never went to a single class. At the end of the term, he heard that Bob Reed, who was teaching thermo, who was famous for difficult problems, had made up his exam already. And he went to him and says, hi, I haven't taken your class, but I'd like to take your final. And Bob Reed thought it was a joke, but all right, here it is. You'll never get anywhere. Well, they solved it, came back in an hour, and got 100% right. Bob Reed was so upset he tore it up and wrote a new one. And then, as I said, he not only pass the exams. He got the second highest raw score ever recorded. So he had a very quick mind. I once gave him a paper and said, you got 30 seconds, and then I want you to tell me what it's about. And he just flipped the pages, scanned it, and he got everything he fully understood. So he was extraordinary, and it was a great pleasure for me to work with him because we could sit and talk for hours, like you said. How many atoms in the universe? Well, you know, we did our best to calculate that. Didn't publish it. Maish talked about Dave Terman. I have to tell you about this. This is what started Regina Murphy's thesis. I had a summer job with Amicon Corporation that was formed by Alan Michaels after I finished my thesis. It was one of the greatest experiences because it was incredibly creative. And I became their biological guy, and anybody who came in had a question about them doing something related to biology and medicine, they sent them to me to find out should they do it. And if I liked it, I said, I'll do it. And so a lot of things I got into came through that channel. Well, one of the things was Dave Terman, who was a physician of some sort in Houston, and he was following up some observational literature by taking cancer patients, humans, passing their plasma over a bed of protein A immobilized on a gel, reinfusing it. Claimed that patients would their tumors would diminish. Yeah, extraordinary things. And he wanted to get membranes and try membranes as supports for this. So I was working with Barry Solomon. The two of us went down there to observe. I'm brought into the hospital room of a patient. He's there, and he's a very gracious guy, and he said to her, and I hardly knew him, he says, here's the engineer who developed your cure. Well, okay, I played the game. She was sitting on a bed. Her breast was exposed. There was a lump, which was her tumor. On top of it was this green stuff. She had a bacterial infection on her tumor and had been treated with this plasma. And her body was going crazy. He took her hand, my hand, put it on her breast. It was physically hot. They put a thermometer on it. I forget the reading. It was either 107 or 104, I'm not sure. Incredibly hot. Her immune system had been turned on up to high by the bacterial infection, and now the whole thing was ganging up on the tumor as well. Everything, our interpretation was, everything that had been hidden by formation of immune complexes was now attacking the tumor, whatever antigens were present. Then he called me a couple of weeks later and said she left the hospital after a week. Her tumor was gone. I mean, this is like so incredible. And I saw it and I felt it. This was very motivating. And I told Maish about it and he went nuts. And that's why we decided, we came up with our simple-minded explanation. We got to look into it. And then once we got into the thermodynamics of immune complexes, examining with fancy electron microscopy, they formed cycles and linear chains. It got very complicated, and we never got out of that till the very end, and we managed to contact a model system with protein A. Never really got into it. And then there was a tragedy of sorts. Terman convinced the hospital to fund a human trial just because this looked so incredible. And they did the human trial, and the results were sometimes it worked and sometimes it didn't. He got very depressed about it. He quit the field and went to become a PCP out in rural, it was either New York or Texas. Just stopped research. What happened? Well, we learned he did a very stupid thing. It was a reactor in which he contacted the plasma. It was a bed of gel particles, like a chromatographic bed. He changed the design for the human trial and made it into some kind of pancake shape. And I said to him, how can you be so stupid? We have no idea what's going on in there. We don't know about contact times. We don't know about the response times. How long should the contact be? You're working in a column, you're dribbling through slowly, you're doing it fast. Kinetics are all changed. Exposure is all changed. And you have no idea because you don't know what's happening. And that was the fault, and that's why it didn't replicate. All right, we got to get out of here. I'm gonna stop. I had more stories for you. Oh my God. I have the best story still to go. I'll tell it tonight.